once we kind of set the context and talk a little bit about some of the commands. And so on the website, and we got these files up just recently, and the the solutions are there, but I'd hold off on looking at the solutions until you've had a chance to maybe kind of, yeah, work with it and see if you can kind of problem solve and figure some things out with it. So, anyways, well, let's get started. I think it's 7:30, and I don't want, it's a busy time of year, and I don't want to keep. There it is. Yep, exactly. So, yeah, if you've got your Innovator handy, so yeah, I'm gonna try to play a couple of things on my end too. So we've tested it with this mic, and it seems to work okay. So hopefully it comes through okay on your ends. But I'm gonna share my screen and the slide deck, and again, that's up on the stemsupports.ca site as well as the TNS files. But the TNS files, again, are kind of the solution. So my hope is that we can kind of do some building together, and then the solutions there are there if you really need them. Well, they're there for reference at the end. Excuse me. Yeah. Anyways. So let me, I'm just going to hope everybody's doing well. I know it's, again, a busy time of year, and uh, just, yeah, if you're in a school, you know, crazy time. I was talking to a friend of mine in Dufferin Peel, and I don't know if about anybody else, but we're allowed in our board, and I thought this was consistent in a lot of boards, to only 20% of the teaching staff has to stay there for the full day. But I was talking to a colleague of mine in Dufferin Peel, which is the board I started off with. It's coterminous with us here in Peel, and they have to stay there for the full day. Everybody on staff, which is it's really kind of made things stressful for everybody on that end. So I think everybody's looking forward to a welcome break. And so, anyways, let's get started. You should be looking at my slide deck. And so tonight we're going to be talking about the Innovator, the hub, and sound, and just trying to explore how to work with some of the commands there, and then maybe thinking about how you could maybe use it in the classroom to do some interesting activities, and kind of integrating it into your teaching, but also thinking about, again, how does it connect some mathematical ideas. So here we go. So it's time for some sound, and I was, I thought about, kind of something. This is one of the earliest memories I have when I was born in Portugal, and so when I came over and I was quite young, this is one of the earliest memories I have of and watching this. I don't know if anybody. Yes, it is Lawrence Welk. Yes, give him a free calculator, Tom. The that is Lawrence Welk. I would. I'm kind of, yeah, I'm not ashamed to say I enjoyed watching Lawrence Welk, and his trademark phrase was and the one and the two, and then once the the a song or something, the band finished a tune, he goes, wonderful, wonderful, that was wonderful. So yeah, I loved Lawrence Welk, one of my favorites. But anyways, I'm going to try to plug in my second monitor here, and that way I can kind of have the chat pod up and ready. So let's get started. So if you've got if you're on what was I going to say? If you're on your computer, hopefully you've got your software started and booted up, and so your instrument/equipment for tonight, you're going to need your hub, and you can see it on the left there, and it's plugged into my computer using the mini USB. So it's all plugged in and ready to go, and it's ready to go as soon as you plug in. You'll see the power light, the power LED illuminated there, and if you recall, Chris did some work as well with the hub, and so hopefully you have some familiarity and played around with it a little bit there. So I'm just going to try to plug the second monitor in. Sorry, folks. Let me just get this ready to go. Beauty. Okay. So so if you haven't got everything hooked up, maybe take a second while I plug in my second monitor. There. Good. Okay. Awesome. Goody goody. Okay. Awesome. Okay. And okay. Perfect. Okay, so now I can. I would have thought you're first. Okay, thanks, Fred. I was born the last year. Yeah, so we're gonna start with that, Tony. So the how do we kind of start? So you've got everything, your equipment ready to go. So before we start, let's just kind of talk a little bit about I guess, some theory. I'm not a musicologist. I'm not, I took a little bit of music and I've dabbled here and there, but just maybe kind of covering some things that are important to understand, especially when we start coding and working with the Inspire. So when you think of that do re mi scale, so to go from the beginning to end, right? That's 7 notes in between the two C's. That's an octave, right? And it comes from the Italian for eight. And so those 8 notes in between 2 notes, and so you arrive at the same note you started with. Now, mathematically, there's actually 12 steps. There's some sharps in between, and so to get from one note to the next note in an octave, and so each of those 12 steps, you're going to multiply by the root of the 12th root of 2, or as a rational exponent, 2 to the exponent of 12th, and that'll produce. So that's going to be important, especially for the coding activity that you're going to be challenged with doing. So doing this 12 times produces the same note an octave higher. Okay, so just keep that in mind as we go through this. And in fact, we're kind of going to demonstrate this. And again, going to Tony's point, how do we start a blank program? And yeah, we're going to multiply by the frequency. Exactly. So we're going to need to know what are the frequency translations between our notes. And so perfect segue, Tony. The middle C, that first note, the frequency is 261.64 hertz. And so at the other end of the scale, once we run through the octave, the treble C, it's an octave higher, would be what? So what would that be? Again, if you're to get from one note to the next, you're multiplying by 2 to the exponent 1/12, but you've got 12 steps, so then that would mean, what would C be? You're going to, exactly, Nancy, you're doubling it, so about 523. Okay, so that's what we're going to work with as we work through some of the sound commands using the hub. Okay.
Mike,
All
can
right.
I just kind of interject one little question? So what is a hertz?
I don't know. What's a hertz, Tom?
It's actually an important thing for understanding kind of why C and C kind of are double each other. Hertz is how many waves there are in a second. So how many sound waves fit in a second, which is tied very closely kind of to our grade 11 and 12 curriculum in Ontario with trig functions. So it's tied to the period, right? So the and the one note that's kind of the tuning fork that people always use is A, because it's a really nice number, because it's 440 waves per second. So it's a really nice one to tune to.
Exactly. Thanks, Tom. Yeah, exactly. 440 is such an easy one to remember for A. All right, so let's actually try to get our hub to play middle C and see what the command looks like. So I'm going to stop sharing my screen on the slide deck, and I'm going to share my Innovator screen, or my software screen. Let me just go over to here, and here we go. Here we go. Okay, so back to what Tony was talking about. So I'm going to go to start a new document. Oops, where are we here? My Seems like my screen, let's try there we go. Okay, so we don't have to start a new program yet. If we want to just play around with some of the commands that we're going to be interacting with, let's actually go down at the very bottom here where we see add Python. We know that 1 for new starts a new program. Right, exactly, Tony. 440 is middle A, exactly. So we know that new will be adding a Python program. We're actually going to go to the shell. So intro to the shell for me, if you don't mind. And you should be looking at something like this. And so the shell, it allows us to do some, do whatever we want, quite honestly, perform some operations, but also allows us to execute some commands without kind of going through the entire process of creating a program. Okay, so let's try to play the middle C and treble C within the Python shell. So if we press the menu button, and there's all the menus, and notice that some of these menus are the exact same menus that we have in when we're coding, right? There's the built-ins, there's the math menu, and so on and so forth. We don't have the control menus that allow us to run stuff because we haven't coded anything. But let's go down to number 7. You can see TI Hub. And once you get into number 7, if you just want to take a look at all those, okay, we've got built-in devices, add input devices, add output. There's some commands. We're going to take a look at some of those as well tonight. And ports. We won't be plugging anything in tonight, but let's go to our number 2 hub built-in devices, the stuff that's already built into the hub. And when we go there, you can see there's 4 options: color, light, and sound. And sound is what we're going to play with. So go to that option, number 3, and you can see there's only 2 options for the sound output: either a tone or a note. A tone or a note. Okay, so let's select number 1 for tone. Okay, so just like in a program, Python's prompting us and giving us some hints as to what we can do. So the frequency, you might have seen it just pop up for a second there. I can input any number between 0 and 8,000. You can try it 8,000 if you want. Probably won't hear much though. But let's put in our middle C. So 261.64. Okay. All right, and then when we press tab, how long do you want the note to play for? Great, put in your A, Tony. Let's say 1 second. Okay, now go ahead and hit enter. What happens?
Error.
Error, exactly. So we should get an error. And does anybody have any idea why we got an error?
And I'm guessing it has something to do with object-oriented programming.
Mm-hmm. Yes. And what do you mean exactly, Tony?
I don't know, but I think we have to have an object.
Right. So anybody else? Anybody want to add on to what Tony's kind of thinking here?
Maybe it doesn't know the object?
Right. Yeah. And so let's go to menu. And you remember when we create a program, we have to sometimes some of the commands might be stored in different modules. And so if we go to menu and go back to that hub menu, so for number 7, the very first one, we didn't import those modules from the TI hub. So let's do that first. So select number 1. And nothing should happen. It's imported, but it has imported those hub menus. And now go ahead and rerun that command. So go and rerun that sound tone command. So that'll be, again, menu, number 7 for the hub. It's a built-in device, number 2. And we're going for a sound output, number 1. And now we should be able to, and pay close attention to your hub because this should work now. And mine was playing. Give me an idea in the chat pod if you had some success there. Give me a thumbs up or there we go. The violin tuner. Perfect. Exactly right. So there it is. That's it. So if you want to try that again, just like with the Inspire, you can go up and grab a line of code, hit enter, and make it the current line. And if you want to change that, maybe I'll change it to Tony's 440. and I'm playing that middle A. Now, there is another way to play a note, and you saw the two commands. So let's go to menu. Actually, let's try. Let's just compare it. We talked about the two C's, so let's try that other C, which was. So let's try to double that 261. So one way to do that, I'm going to go up and I'm going to grab that sound tone command, that one that I just had. Oh, I just lost the chat. There it is. And instead of just, if I don't remember it, I can just hit ×2. Let's just hit multiply that by 2 so I can double that tone. And here we go. And that should play the treble C, so 1 octave higher than middle C. Exactly, yeah. So yeah, so that's it. It's as simple as that. How to use that sound tone command. Now let's go and try out the other sound commands. So let's go to menu and down to hub again, our built-in devices, and down to sound output. And instead of the tone, let's use the note command this time. So number 2. Now notice it's even giving you an example in Python. So it disappeared on me, but there it is, example A4. So that would, if we do that, that should be our middle A. So let's do that. Let's type in A4. You don't have to capitalize it. And then I'm going to tab over, play it for a second, hit enter, and you're playing A4. So you have two ways to enter in notes, either the frequencies, or if you, so that's A from the 4th octave. If you know the note you want, you can just select it as, so you're going to need, the format of a note will always be the letter followed by the number, including sharps. So if it's A sharp, it'll be AS, then the number. So let's say I'm going to try an F sharp. So I'm going to go up to that command, put it in the current line. Again, to put in the current line, I pressed enter, and then just backspace the A, and I'll put FS. So that's going to stand for F sharp, and that's there. Okay. All right, so that's it. That's really all you need to know about the syntax of the tone command or the sound commands. So now that I've kind of shown you a little bit around that, I'm going to go back to my, I'm going to go back to the, and another thing we can do is if we wanted to play a scale. So remember, the next note after middle C will be, I take middle C and multiply it by 2 to the exponent 1/12. So I could, if I wanted to, let me grab this command, multiply 261.64, multiply that by 1 to the exponent. Now, this will be interesting. The exponent in Python, exponent, if you're used to the calculator, the Inspire, we know that the exponent key is that, but notice when we hit it, it's the 2 multiplications. Yeah, Control C. Oh, the 2 multiplications. So that's different than what we're used to, especially if you're an experienced Inspire user or 84 user. That exponent kind of icon in Python is 2 multiplications. So if I hit that, and so 261.64 multiplied by 1 to the exponent 1/12. So now I'm playing 1 semitone higher, right? Right. B flat, BF. I haven't tried BF. Let's try it. Okay, sure. It gives an error sound. For which one, Tony? The Tom's suggestion of BF?
I actually tried FF.
FF?
Yeah, F flat doesn't exist. So in that that's one of those things, like if you can picture there, because there's a semitone between E and F. There's no space for an F flat.
Okay.
Yeah, it's enharmonic to E. That makes sense. Okay.
Yeah, it's one of those oddities in this scale. Yeah.
All right. Okay, so now that we've kind of seen that, again, I can, I'm going to get you to try to code, and I'm going to go back to my, I'm going to stop presenting this screen.
Paul, can you one little thing that can you just go back to the screen for 1 second? Because Paul was living in what's called the Python shell there while he was doing that, which was different than the Python program that he started in. So it was interesting that he could do programming in the Python shell. That's kind of a cool thing to do, kind of to interact with something just it's like a play space almost in there.
Yeah, that's exactly it, Tom. It's a nice way to kind of test commands and see how they behave without having to write a full kind of code, full program for it. So yeah, this is a nice way just to kind of pull commands in and see how they behave and test them and stuff without writing that full code. But let's go to writing a code. So it's in my slide deck. Maybe I'll just read it out. What I'd like you to do is create a program that produces the scale from middle C to treble C. So we're going to go from middle C up to treble C. Okay, so that's the challenge for you. So let me just start off by maybe reminding us how to start our Python program, and then I'll give you a couple of minutes, and then maybe if you get stuck, and we'll kind of keep an eye on the chat and see how you do. So here we go. Let's press menu, and this time we're going to go to, sorry, I'm going to add a page. Control doc. I'm going to add a page.
So that's in part answer to Tony's question too. Another way to get that add Python, Tony, is to just do control doc, which inserts a page.
Right.
And it asks you what kind of a page do you want to stick in.
So then we're going to go to our new Python program, and let's call this scale. Okay. Now, before we move on, we know that we're going to be interacting with the hub. So let's pull in that module now, so we don't have to remember once we get the program open. So I'm going to select Hub Project, and that's going to pull in all the modules we need to run our program. So I'm going to hit OK. And there we go. You can see the hub was imported. It also pulled in the math modules, the plot libraries, and a whole bunch of stuff. All right. So now I want to write a program that starts at middle C and increments by each of those 12 notes and ends at treble C. So I'm going to start it off, but then I'll let you go. Sorry, Nancy, just which part? Just the goal of the challenge?
No, so I lost you after control doc.
Oh, okay. Sorry. Okay, I'll start that again. Let me just do that. So again, control and then doc, and it puts in a blank page. And I now want to go down to add Python and select number 1 for new, and then just name the program.
Okay.
And before you go on, let's select the hub project type so it imports the appropriate modules. Okay?
Thank you.
You're welcome. Okay, so the first thing is I'm going to start off by finding the starting point for the frequency. So frequency will be equal to what was it? 261 was it? 0.64? Someone refresh my memory. Yeah.
Yep.
There we go. All right. Okay, I'm going to let you go for a second and see if you can figure out how do you now you're going to produce the scale and go from middle C up to treble C. And don't forget that each subsequent note will be, we're going to multiply by 2 to the exponent 1/12 to get the next note. Okay, so why don't I give you a couple of minutes and see if you can figure out what program structure we'll need, and also maybe some of the logic that you need. All right. Let's just jump in and just see how you're doing. Probably not, I don't think you might not be done by this point, but can someone kind of help me out and tell me what structure are you using to increment from our starting frequency and get it to our ending frequency of treble C? Anybody want to share that in the chat or unmute yourself?
A for loop.
So thanks, Tony. Exactly. So I'm going to start off with a for loop as well. So number 4, built-ins. We're going to go to control, and we'll use a for index in range size. And so my my index will be I, and the size of the loop will be 12. All right. Now, does anybody want to help me with what is the actual, what should be in the for loop? What should we put in the for loop? Anybody got that? So we're creating the next note after middle C. All right. Well, hopefully, oh, there's Tom Scott. So I want to multiply the starting frequency by 2 to the exponent 1/12, right? And so I can press the variable key, and that should store the variables that have been declared already. So you can see frequencies there. So I'm going to hit equals, and I'm going to take the previous value of frequency. So I'm going to hit variable again, multiply it by 2 to the exponent, and again, notice the 2 multiplications. And in parentheses or brackets, 1 divided by 12. And there we have it. Okay, now, so that should calculate the next note. Now what we want to do is play it. So we're going to hit enter and go to our menu, go down to our hub menus, number 8. Number 2 for our built-in devices, and we're going to access that command that we were accessing in the shell. So number 3 for our sound output, and number 1 for our sound tone. And so for our frequency, we want to use the variable frequency. So I'm going to press variable. Oh, where is it? I think I might just have to type it in. I should have been able to just pop it in there. And then for the time, you can select whatever time you want. So let's say, let's play for 1 second. So we'll go through the musical scale from middle C up to high C, and we'll let each note play for 1 second. So that looks pretty good. Has anybody got it?
Did you want to make the tone line before you change the frequency?
Okay, so
but
I was wondering.
know, sure.
Okay, so why would we want that, Tony? Why would we want that?
Well, the first tone should be the original frequency.
Right. So if we don't do that, we're going to miss middle C. Exactly. So the
But
order.
I don't think we would notice that actually, unless we had perfect pitch. So.
Yeah. Well, unless also maybe you're counting. Maybe if you're counting, you might miss it too. But yeah, you probably would. So that's one thing. So let's just play it. Let's actually just play it, and then let's talk about modifications and kind of refinements to the code. But does anybody else want to mention something? So that's a great point, though, Tony.
Actually, we'll probably just go through a different mode of the scale. I don't know.
Okay, no, that's fine. Does anybody else want to mention anything? Any issues? No? Okay, well, let's play it. So remember to store the syntax, to check the syntax in store, we're going to go Control B. And you can see at the top, we saved it successfully, then Control R. Here we go. Okay, what did you notice? If you got it to run.
So for mine, I didn't actually do it your way because I just had one line in the for loop, which was the frequency, and then I kind of used the index of the for loop to kind of multiply by the right exponent. But in any case, it only played one sound.
Right. So all the sounds kind of just piled in together. So one thing we're missing is is slowing down. Yeah, slowing everything down. So what do you mean, Derek? Where do we need that I? Oops. In the frequency command. Okay, so in frequency, where would we put that there? So can you give me the exact place you'd want to put it? Oops, I'm missing my. Mm-hmm. In place of 1, exactly. Yeah, so that's it, exactly. So I'm going to put an I there. And then also after that sound tone, I'm going to press enter, and I'm going to put in a sleep. It's almost like if you're used to, if you've used the hub before and used the basic, used TI basic, it had the wait command. So we wanted to just wait and execute the previous command before going to the next iteration of the for loop. So let's press menu.
I'm not sure I understand why you put the I there, because each time you go through the loop, you're multiplying the frequency by the 12th root of 2. But now you're not doing that all the time. Now sometimes, like at the end, you're multiplying by 2. But that I, using the I makes sense if you're like defining the frequency at every stage, which is what I did. But yours is more like kind of like an incrementing thing.
Okay, so how did you do it again, Tony?
Well, Tom put it in the chat, so I just did exactly that.
Oh, sorry. Yes, I forgot. Yes, my goodness. Yes. So the frequency times 2. I see. So that's we've
the
got
1 over 12 made sense.
The 1 over 12 makes sense, but okay. Well, let's put in, first of all, let's put in the sleep command and let's see how this runs. You get it to run your way, and let's see if we get the same sort of incrementing scale. So here we go. We do need the sleep command to just wait on the execution of that command. So we're going to go to TI hub and commands. Oops, that was a little too quick. I got my while commands in there. So you're going to go to TI hub, in there, menu, and hub. And instead of the built-in device, you're going to go down to number 5 for commands. I did it again. I don't have my mouse. That's why. Oh, what is it there? 8, 5. There it is. And it's very first one, sleep. And let's put in sleep and wait for 1 second. So now let's store and let's play.
Wow, that didn't sound right.
It might be a scale somewhere in the universe.
Yeah.
Mine worked using what Tom put.
Yeah.
But I think your way works if you make the I into a 1. Yeah. But I predict it will be like a different
so think about what just happened there. It's interesting because when you multiply the first frequency by 2 to the 0 12ths for the first, because I starts off at 0, right?
Right, exactly.
So that would have played C, but then it multiplied that by 2 to the 1/12th, which would be C sharp.
Yeah.
But then it multiplied that by 2 to the 2/12ths, which would have bumped it up 2 semitones or a full tone, right? So it's going up by a semitone, a tone, it's like 3 semitones. So it's going up by larger and larger increments, I think.
Right.
Okay? An interesting one.
All right, so let's try that one more time. Awesome. So that played well. Okay, so we've got our scale. Now another thing we could do.
Actually, it's in the Dorian mode because you're actually starting on a D. So if you want the standard Ionian mode, you have to put the frequency thing after the sound dot tone.
Right. Yes, right, because we're missing the initial C. So the order of our statements is we got to fix it. So I'm going to take the frequency. Now the other thing too, and in fact, so one thing that it's in the challenge that I'm going to ask you is let's also display the frequency as we're going through. So after our sleep command, let's put in a print command so that we can see what is the current frequency. And let's actually put it at the right after the for loop. So I'm going to move my cursor to right before the frequency line. I'm going to hit enter, and let's put in a print command. So that's menu, number 4 for built-ins. And you might remember this. This is an input out command, and number 1, and we'll do frequency. Okay. So we'll be able to see the frequency as it's going through the for loop. I think I'm going to do exactly what Tony suggested. I'm going to put in the sound tone so it starts at that middle C, and then I'm going to get rid of that line after my frequency tone. And then what we're going to do is we're going to try to do this again, but but using the notes. We'll talk about how do we actually use the notes for this. So I'm going to go to number 8 for DI Hub, a built-in device with a sound output, and number 1, we're using frequency. Time will be 1 second, and I'm going to get rid of this line right here.
I don't know why, but it sounds the same even with frequency after. So I can't explain what's happening.
Got it. Now I am missing the last value because it printed. Oh, yeah, no, it should, no, it printed before it incremented. So I could, if I wanted to, add one more line at the very end. So after the for loop, so make sure you're not in the for loop, and ask it to print the final value of the frequency. And then I should be able to see it. Yeah, so we can see the final value, the final frequency of treble C at the very end there. All right.
You know what? I think what I was saying was complete nonsense, because we're actually just going through all of like the 12 tones.
Right.
For some reason, that didn't click. I was listening for a scale, but it's not really a scale.
Okay.
To do the scale would be a bit trickier.
Well, let's try. Well, let's see what this would have looked like if we would have used the names of the notes rather than the frequencies. Okay, so let's try that. So let's start up a brand new document. So your new challenge here is going to be to write the exact same program, except we're going to use the names of the notes. And so this is going to require a slightly different type of for loop. Okay, so here we go. So I'm going to start a brand new document. And I'm going to go File, New TDI Inspire Document. I'm going to go down to my Python editor, New, and let's call this, we can call it maybe Scaled Notes. Okay. And again, pull in the hub modules. Beautiful. And there they are. Okay, so with the previous program, we had to set the frequency initially, but for this one, we don't. What we're going to do is we're going to pull in the values into a list. So I'm going to press Menu, and you can access this command in a couple of places. It's in built-ins, number 4, and it should be in the control. Okay, and you can see it's number 7 for index in list, number 7. Okay, so is everybody okay with that? Okay, see ya, Chris. All right, now the index here is going to be the name of the list. So let's call it notes or note. Okay. Press tab, and we're going to go over to the next chunk of the code. And now here's where we're going to put the list of notes. Okay, the list of notes. Now, to put in a list, you're going to need the square brackets. So you can find that in a couple of places, obviously on your keyboard. If you're on the handheld, it is right above, next to the 0, you can see the round brackets. The square brackets are on the left right there. So if I press Control, you can see it there. It's also actually in a menu as well. If you go to Menu, number 4 for built-ins, and go to Lists, you can see it's in there as well. Okay. So a bunch of places you can find the square. This is the list bracket. So make sure the cursor's inside those brackets. And now let's put in the names of the notes. Now to put in the names of the notes, they have to be in quotations. So here we go. You can get the quotations again off your keyboard, but if you're on the handheld, it's Control multiplication. And let's start with C4. We won't do all of them. Control, and then comma. And then you separate all of the subsequent notes with a comma, but it looks the exact same way. So the same kind of syntax. So C4. If you want to just go in order like that, you can go D, E, and so on. So we can just do the 7 notes if you want. So the do, re, mi, and so on. So let's try that. So let's try D4, comma. We'll go E. And the syntax should always be the letter of the note followed by the octave, and then Control. This will be what am I up to? F4, comma G4. Oops. I'm just going to switch over to my keyboard here, and then we've got A4.
Is it A4? Just a quick question. Does does the octave kick over when you run out of letters, or should that be A5, B5? No.
No. Well, we'll see. We'll see. Maybe does this make logical sense? I think I'm going to end at C5. Right.
Okay.
There we go.
Right.
Now I'm going to press Tab to go into the block, and this time I'm going to go into the menu, and I want to access the hub command for the sound, but the note one, the note one, not the frequency one. So I'm going to go Menu for hub and the built-in device sound output, but this time number 2. And for note, you don't want to actually type in a note. You want to pull in the list. And so you actually don't even want the parentheses. So I'm going to delete everything there and you can press, no, the variable key doesn't work there either. So note, and then select the time, and we'll do 1 second again. All right. So is everybody all right that? Okay, so you've got we pulled in the for loop for lists, we put in our lists, and then the sound, we're using the sound note command, that output command. It's where the argument there is the note, which is the lists. I want to play for 1 second, and it's also put in our sleep command so that we can wait in between notes. So that's again menu, number 8 in the hub, and number 5 for command, and number 1 for sleep. And there it is. Okay, Control B. The syntax and saves, and try to run it. There it is. Okay, that's it. So hopefully that ran okay for you on your end. I'm going to just go back to my code just in case something went awry on your end. But that's it. So you have 2 options for producing sound, either through the frequencies or through the names of the notes. Now, another thing you can do, like we got it to print out, and this is kind of nice in terms of presenting or outputting the actual, you can use the print command again, or here's another way you could do it. You can go menu, and we're going to go down to the hub command, so number 8. And I'm going to go to the commands again, and notice there's a text at command, number 2. Okay, and this is a way to also print outputs, but to a nice clean screen. It actually is nice and blank. So if I select that, number 2, it's going to there's 3 arguments. What row do you want to print on? There's 13 rows in the Inspire screen. So 6 is roughly in about the middle. what is the text of it? Well, the text of it should be the current note. So it's the list again. So note. And pressing tab one more time, we have 3 options for alignment. We'll center it in the middle of the screen. And so now if I store that, it's saved. If I run it, let's see what it looks like. Now notice, like, if you notice, if I run that again, okay, to get rid of that screen, I'll just press enter and it goes to the shell, and I go back to my program. If I run that again, notice that the command, like, it's pasting everything on top of itself. So the screen is based, so it starts with C4 and puts D, E, and so on top of it. If you'd like to kind of wipe the screen clean and then put the next text command, what you can do is after that text stack command, I'm going to press enter, menu, number 8 for hub, and commands. You'll see the third command is a clear screen command. So number 3 will clear the screen. So basically erase the screen and then puts the next command after that. But notice, just like what Tony said with the previous one, with the print command, I probably would want to have this before the sound note, so it could start on C4 and then go to D4 and so on. So in other words, I should, if I want to, and the nice thing about Python is the copy and paste feature works nicely. So if I cut that out and put it before, it should start at C4 and run nicely here. So let's try this one last time. Oh, I think, oh, I've got the clear screen in the wrong place. I should have put it at the very end. I copied both lines of code, so it keeps erasing everything too quickly. I'm going to put that there. All right, so we've seen, so the next thing obviously is, now you're thinking, we know how to create sounds using frequencies, we know how to create sounds using notes. I wonder how I could actually write a song using the hub, and kind of, so I'm just going to go through quickly how you do that, but let me just run this and just see how well it looks. There it is. So notice it started on C4 and should end on C5. It might end up really quickly and then erase there. Perfect. All right, so a couple of ways to output stuff on the screen. You can use that print command, or you can use that text stack command, which is available in a few of the modules as well. I'm going to go back to I'm just going to stop sharing the screen for just a second and go back to my slide deck. So I just want to kind of share a couple of things before we move on to just talking about making music. And yeah, here we go. Where's my, oops.
I'm not sure that, like, when it's, you mean when it's in the middle of something, kind of to break out of it, Tony? Yeah.
You can just unplug it. Just unplug it, and it should stop it there. That should break it, Tony. All right, so we did a couple of challenges, and so hopefully kind of got a sense of how to do that. And we talked about creating this from the notes and then displaying using the text stack command. So now playing a song, you want to be familiar with the notes of the song. Yeah. To the note, you want to be familiar with the notes of the song, and then kind of all those translations. You want to have them at the kind of your fingertips. Those translations to frequencies, or if you want to play it, so you can play it using frequencies, or you can play it using the names of the notes. You can find these all over the internet. These kind of translations of notes to frequencies. So here's another example that takes each of those notes, the names of the notes, and translates them to their frequencies. Although this one is missing a couple. I notice it's missing, a couple at the beginning and at the end. So to play a song, the if you've used TI Basic, there's a nice way to kind of just build in two lists, and in one list have the names of the notes, and the other list you have the how long you want the notes to play. So I'm going to play something. Let's see if you can name that tune. So let's see. I just need to pull it up in my Inspire, and let's see. And then I'll show you what it looks like, and we'll finish with this because well, we'll look at the code and we'll see what was involved in creating the song.
Let them know how you got it to sound louder for everyone, because I think
sure. Yeah.
that's interesting.
Okay. Yeah. Well, I'll show you my high-tech setup. So here's my hub, and I had to get some key piece of technology. So I've got a bowl, and this is sitting in there, and it's amplifying it a little bit. So here we go. I'm going to play this song. Let's see how well this runs. Okay. Does anybody know the song? Tony, you got an idea? Anybody? Okay, anybody? Okay, go ahead and put it in the chat pod. What do you think it is? Yes, 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 yes. So I'm going to share my screen and just show you the process of creating a song. It is a little laborious because, well, you first have to get the notes, and then again, you can just get the names of the notes, and so that's what I did, and then try to figure out the timings. So it wasn't perfect. It wasn't perfect, but it was, but it, good enough that you could figure it out. So this is what the code looks like. And let's just see if we can decipher it and make sense of what it's doing here. Okay. All right. So I imported the, hopefully it's showing up on your end. I imported those modules just like before, and you can see I've got two lists this time. So just like we did when we were playing the scale, we've got a notes list, and that's containing all the notes I needed. So it is fairly lengthy. Okay, but the nice thing is it's done. So I can modify this for any song. It's not for "We Wish You a Merry Christmas." It could be for any song. And then I've got a second list, which is my timings list. So I could probably have played around with this and fine-tuned it a little more, but one for a quarter note and an eighth note was half of that, 0.5. And then I've got my for loop. And this time I didn't use that for list command. I used a for loop with the range command. But notice to set the size of the range, I had to know how long my list was. And so in the menu options, number 4 for the built-ins, going to number 4 again for lists, you'll see a length command. So that tells you the length of a list. And so that sets how often, obviously, how many times I'm iterating through the loop. And then it's the sound note command, and the note it's playing is note, and then notice in parentheses it's I, so that's telling me which element within the list I'm playing. And then for the timing, instead of the actual time, I'm using another list, and again, for the for loop is defining which element in the list am I playing, and then I've got a sleep command as well. You could probably have a third list if you wanted to, that controlled how much you slept. So maybe if you've got a rest here, or if you want something playing a little quicker, one behind each other. So that's it. That's how you make a song using two lists.
If there are repeated passages in the song, is there a more efficient way to do that? Like concatenating the list or something?
I'm wondering if you could even do it as do some block coding. So like have one block and pull that in. That's what I was thinking too, Tony. Like if you've got a chorus that's going to be the same the same sequence of notes, then if you could just pull that in as a block code. And I was thinking about that as I was looking through, and I was trying to see, but the first couple of lines of "We Wish You Merry Christmas," there wasn't this kind of repetition in it. But you could probably just do a block and just pull that in as a sub-program in it.
One other question too, Paul. Do we have to scale the sleep time to be proportional to the note length time? So I wonder if the sleep needs to be somehow. I'm not sure, because it's according to the times that you have, it should have sounded correct, but it sounded like it was kind of.
Yeah, I think I need a third list to control my sleeps. Exactly. I think yeah, I've got to think about how much time there is between the quarter notes and the eighth notes, so that it is, as you said, proportional between them. So I think to fine tune it, I'd probably put in a third list for my sleep times, and within the sleep command, I could call those in.
Or could you multiply the sleep time? So sleep open bracket 0.5 times time, the I element of the time.
Oh, okay. Well, I could try that. Let me see. Let me see. Let me see how this runs.
Then you'd only need one list. That sounds really good.
What do you think? How did that sound?
Cut the work in half.
Yeah, that's true. Yeah. Let me just finish up by just. Well, is there any other questions? Any other kind of fine tuning to this? I'm actually going to save that, and that's the one, because I didn't put that. We didn't share that on the site yet, because I didn't want to kind of give it away, but we'll post that on the STEM support site as well. And again, you can use that as a shell now to kind of write anything if you wanted to as well. Let me just go back to the slide deck, and we're going to wrap things up here.
Although I guess you still need you need those two lists still, because you need to know how long each note is.
Right. Yeah. Where is that? Here we go. Okay. So just to finish up, I have one more slide at the end here, and it's so we talked about the tune, and so using lists to make music. And so just to wrap up, and a couple of things just to remind you. So if you want to kind of play a little bit more around with the hub, and not just the music, but all sorts of things with the hub, and maybe look at how to play a little bit more around with sound, and the 10 minutes of code on the TI site, it does have a branch for Python with the hub. And so I'd highly encourage you to play around with that as well. And these are all linked in the site, in the slide deck. So if once you go to the stemsupports.ca site, but also, as Tom just put in there, we do have, I lost my mouse here. So these are linked. So this will take you right there. The other thing you might want to have handy is the programming guidebook, which is also on the TI site. I thought I had this linked, but I'll check that link again. I'm going to fix that. So that takes you to on the TI site. It takes you to a PDF that is pretty handy. It has all of the commands. It busts out all of those menus and shows you all of the commands, and it also shows you some of the syntax of the commands, so that if you quickly want to know how to something work, you can kind of have a reference guide right there handy. And as Tom just said, and this is linked in the slide deck, just went live today, is the new the education.ti.com Canada site. And so if you want to visit there, there's a ton of resources. Obviously, the stuff that we've shared through stemsupports.ca, and it's also linked here, but also some other great resources. So like if you go to the resources, it shows you some of the curriculum connections between the different the different curriculums. And is that correct, Tom? Is it here? Oh, there it is. Curriculum alignment. Yeah, there it is. And so you can get the curriculum alignment documents across the country, but also all of the other resources, events, and stuff. So yeah, this just went live today. So
can you do me a favor for a second?
Yeah.
Can you just go to resources or learning tools? I think it's under either of them. Go to learning tools and scroll down. One of the things that at the very bottom, there's two things. Not everyone has all this stuff, and I'm not sure how many of you guys are aware of this, but there's the workshop loan program that TI has had forever. So if you click on the Borrow TI Technology button, you can request, you fill in a form and say, hey, I'd love to play around with, so you go to the workshop loan, just click on Canada, and you say, you know, I'd like to borrow a class set of TI Innovators or Rovers and stuff for, you know, 2 weeks, and I live in Winnipeg, and I'll ship the stuff out to you for 2 weeks. So even if you don't have the stuff, if you'd like to play with the stuff, just know that the workshop loan is there for you.
Yeah.
Especially stuff like the Rover too. I mean, Rovers aren't necessarily things that people will have. So keep that in the back of your mind.
Is it a class set or one?
Either. So if you want a class set, we'll send a class set. If you want one, we'll send one.
Excellent. Thanks. Yeah, this is just want to kind of give a shout out to Tom. He's really done a ton of work in leading us here and really trying to rejuvenate kind of the use of technology in an appropriate way to support student learning. And so this is just another step in kind of providing resources for teachers. So yes, share the word, share the this is great, like the upcoming events. And so there are some kind of further supports. I think this is the OEME conference. Yeah, we're going to have some of the virtual stuff. That's the Edmonton right out west and stuff. So lots of stuff there.
We want to give away our two. So go to the February 13th one right now. That's good. Yep, the conference, February 13th. And just click on the conference there. And I think there's only probably 2 people on the call that don't already. So Tony, if you'd like to get a free registration to this, let me know, kind of thing, and I'll give you a code that'll get you into the conference for free if you want. Okay. It's a virtual conference running in February, so if that's something of interest to you, let me know.
Yeah, it's always
beautiful.
Always good.
I'll stop the recording now.
Thanks.
And